Okay, so let's knock out a free response problem here. This one says let f be the given, let f be the function given by f of x equals x cubed plus 2. I'm going to highlight that sucker if I can. Oh yeah. And we'll let g of x be the function g of x equals mx. All right. Where m is the non-zero constant such that the graph of g is tangent to the graph of f. So that word tangent's kind of a big deal here. All right. What that tells me is that my functions touch there and that the y values and the slope are equal at that point. Here's what I mean by that. So we know that the x cubed plus 2 looks something like this, right? That's what a cubic looks like usually. This one's shifted up 2 units. And then the tangent line, so, it hits this thing somewhere. I'm just picking a point. Let's just say it hits right there. Right? That's g of x. So f is my blue one and g is my red one. Oops, that was supposed to be red. Let's see if we can do this. All right, so knowing that, I know that those graphs touch there, which means their x and y values are the same. And I know that because it's tangent there, their slopes are the same. So I'm going to set up a system of equations with 2 variables and 2 unknowns. The first thing I know is that the y values are equal. In other words, the function values are equal. So I'm going to say x cubed plus 2 equals mx. I know that's true at those points. See if I can make this pencil a little bit darker here. I also know that the slopes are the same, right? That's the whole point of the tangent line. That means that this slope over here is 3x squared, and this slope over here is m. And what I've created now is a system of 2 equations with 2 unknowns. And from algebra class, we know we can solve that thing. Let's do substitution. We'll take this 3x squared and we'll replace m with that. I'm going to put it there and then I'm going to solve that equation. When I replace that, I get x cubed plus 2 equals 3x squared times x, right? I put that 3x squared instead of the m. And now I've just got an equation with 1 variable and 1 unknown. This one's pretty easy. So this is x cubed plus 2 equals 3x cubed. I can subtract x cubed from both sides and end up with 2 equals 2x cubed. I'm going to write that as 2x cubed equals 2. And then when I divide by 2, I get x cubed equals 1, and then I think you can see that x equals 1 here. Okay. So we've now got our, I'm going to put those over there. We've now got our x value. And now we can use substitution again. I can take that x value and just stick it back in. Oops, I don't want that. I'm going to hit undo on that. This is what I want here. Take this x value and plug it back in up there. Okay? And when I do that, I get 3 times 1 squared equals m. And that means m equals 3. And that's what I was looking for to begin with, right? I was looking for x and m, so there we go. I've got my m equals 3. So in terms of my answer for letter A here, if we want to be concise, let's just say x equals 1 and m equals 3. That's for letter A. I didn't label this here, but that's letter A. Okay. Now let's be a little more specific. If you do actually graph these functions with your graphing calculator, remember we're in a graphing calculator part of the test here, so you can use that. What you're going to see, and I'm just going to continue my sketch here, what you're going to see is that this line keeps going and this part keeps going, and we create a region, right? We create this little region here. We're going to call that region R for letter B here. So to figure out the area of that region, we're just going to do the area between curves. We're going to integrate top minus bottom. So for letter B, I want to do a definite integral. We'll talk about how to get those points in a second. But my definite integral is just going to be, looks like f is on top, and g is on bottom. So I'm going to do x cubed plus 2 minus 3x. Because now, remember, m equals 3, so that function's really just 3x. But I need to figure out what my limits of integration are, so I need to find these 2 points. And when you look on your graphing calculator, you'll see that this one here is -2 and this one here is 1. And so I'm going to put those numbers in on here. And then I just have the calculator compute this definite integral, right? This is a Math 9 situation. Math 9. And when you enter this in using NDerive, or if you have a newer graphing calculator that looks like this, you're going to get an answer. And your answer is just going to be, I have it right here on my screen. Where is that stinker? Oh, for God's sake. Here it is. 6.5. 6.75. That's what mine came out to be, 6.75. So it's just a matter of typing this in on your graphing calculator and then making sure that you have the numbers right, and we get 6.75. So that's the area between the curves. And then finally, we're supposed to take that region and rotate it around the line y equals 3. Now again, looking at the graph here, my graph is just a sketch, but when you graph this thing, y equals 3, it's up here. Okay? And so we're going to, this is essentially a washer method, right? We're going to take that typical cross-section, which looks like a terrible washer, and we're going to do the definite integral to compute that volume. And so for that, we're going to do, pi times big R squared minus pi times little r squared. Just keep in mind that the big radius goes from the axis of revolution to g of x, and the little radius goes from the axis of revolution to f of x. So it's going to be v equals definite integral from -2 to 1 of pi times the big R squared, which would be 3 minus 3x, that's g of x, squared. I got to put parentheses here, minus pi times little r, which goes to f of x, so that's going to be 3 minus x squared minus 2. You got to distribute that negative sign, squared, and then dx. And again, we can use our graphing calculator's Math 9 function to do this definite integral. And when I did that, it popped out as, and mine's got pi multiplied and everything, 163.587. I think it works out to be something like 52.071 pi. If you factored pi out, but I just put it in there. And so that's letter C for the front page. So for that problem, this is what we kind of have here. We have to set the system up to solve for m and x in letter A. In letter B, I guess I could write my answer in here. What did I come up with? 6.75 for that one. And then this one was 163.587. I want to make it official. I'll leave a copy of this as a PDF so you can look at it too. But there's my video solution with a terrible drawing. But once you get that value of m by realizing that those things are equal, then you can use that to solve the last 2 problems. So this one's doable. It was hard to get out the door on this one because of the way they describe these functions. But once we figured out what g of x was, it was something that we could handle. Okay, I'm going to slide over to problem 2 here and take a look at that one. It's slightly more complicated, or at least there's more words. So here's that one. And this one says that the rate at which people enter a movie theater on a given day is modeled by the function s, defined by s of t equals 80 minus 12 times cosine of t over 5. So the first thing I want you to realize is that s is a rate, which means it's a derivative, right? It's a rate. It is not the number of people, it's how the number of people are increasing. That's the number of people that are coming into the theater. The rate at which people leave the theater, also a rate, is modeled by the function r. And r is e to the 12 e to the t over 10 plus 20. Both s and t are measured in people per hour. And these functions are valid on the interval 10 to 22. At time t equals 10, there are no people in the theater. So that's kind of our starting point, all right? For letter A, to the nearest whole number, how many people have entered the theater, the movie theater, by 8 p.m., which is t equals 20. So they want us to figure out how many people have entered the theater, which means we have to do a definite integral on s of t, which is the rate at which they're coming in. So for letter A, we're going to set up a definite integral from 10 to 20, because we start at 10 and we stop at 20, of 80 minus 12 cosine. I'm going to write x over 5 just because my handwriting will be a little better, dx. And when I type it in on my calculator, I'm going to use the letter x to do my math 9. But essentially, we just math 9 this thing, right? And when you do that, it comes out to be almost dead on 900 people. It says round to the nearest whole number. And I got 899.965, so I'm going to write that. And I'm going to actually do a squiggly line here to show that I rounded it off. But that's basically 900 people. So that's my letter A. I just integrate the S function because that's how many people are coming in. Letter B, slightly more complicated. They want us to, the nearest whole number, find out how many people are in the theater at time t equals 20. Well, we know 900 came in. We just have to subtract off the number that left, which means we got to integrate from 10 to 20 the other function, r of t. So I'm going to integrate 12e to the, I'm going to say x over 10 plus 20. And then when I type that into my graphing calculator with math 9, right? When I type that in, oh, that came out to be, let's see, do I have to round to the nearest whole number on this one too? Yeah, letter B to the nearest whole number. 139 people, I think. Yep, because I came out with 139.47, so I'm going to round that off to 139 people. Right, it's the 900 that came in plus the ones that left, or minus the ones that left, and that ends up being 139. Okay, for letter C it says, let P be the function, definite integral from 10 to t of s of t minus r of t dt. In other words, we're kind of totaling up the number of people that are in the room at any particular time. We want to find the value of p prime of 20. All right, so there's a couple things that's going to happen here. First, I need to know what p prime of t looks like, and then I can plug in 20. So p prime of t is just the derivative of this thing, and this is a definite integral, right, with variable up there in the top of the limits of integration. So p prime is just going to be s of t minus r of t. And so if I do that math, S of t, I get actually negative 20.825. Actually, let me rewrite this because that's, I got to, so that's the formula. And then if I'm doing p prime of 20, oopsie, which means I'm doing s of 20 minus r of 20, and I do that right on my graphing calculator. That ends up being a negative 20.825. All right, so that's the value. That's the value. But they want us to also explain what it means, right? Explain the meaning of p prime of 20. What this means is that we're at that moment at 8 p.m., the rate at which the number of people in the room is changing is negative 21, right? Approximately negative 21. In other words, we're losing about 21 people per hour at that time. All right. So in terms of my explanation, I say, oops, I got to use the right pen here. We are losing approximately 21 people per hour at 8 o'clock. Right, that's what it's saying at times t equal 20. The number of people in the room is reducing or decreasing at 21 people per hour. I guess I could say it that way too. So this might be a better way to say it. The number of people in the room is decreasing. That's a good word. At a rate of, I'll use their language. I'm trying to write it so you can read it though. At a rate of 21 persons per hour. All right, that sounds pretty good. We're losing 21 people per hour, approximately 21, or the number of people in the room is decreasing at a rate of 21 persons per hour. Okay, and then finally, we're supposed to do letter D here. What does it say? At what time t for 10 is less than or equal to t is less than or equal to 22. In other words, t is between 10 and 22 is the number of people in the theater at a maximum. Okay, so we already know the formula for the derivative, right? The derivative is just s of t minus r of t. P prime of t equals s of t minus r of t. And so if I just graph that thing and look to see where it crosses from positive to negative, I can find the answer. And I did that. I graphed it on my graphing calculator. And P prime of t crosses the axis from positive to negative, from top to bottom, in other words, at t equals 17.776. And if you were graphing this thing with x as your variable, across the x-axis is 17.776. That's the way we figure out, where something's a maximum. If it goes from positive to negative, it's like doing a sine diagram. If it goes from positive to negative, then we have a maximum there. If it went negative to positive, that would be a minimum. All right, so let's see. I guess I could highlight these other answers here so that this looks kind of official. But that's the basic deal with these. I like sitting around talking about math, so the video went a little longer than I expected. But hopefully that'll help you. And then I'm going to make a PDF out of this page, and I'll post these as well. All right, that's enough for now. Good luck.